Okay, so now that we've written out our steps, our job is to really find patterns and then describe those patterns using English sentences so that we have an outline for what our code is supposed to do. It's much easier to just write out in normal English sentences what your code is supposed to do and then translate that to actual code than it is to try to think in the code, right? And we know certain structures exist, and so like we know loops are a thing, and so they help us repeat instructions, right? So we can look through here and see, are there any kind of repetitive parts? And then we know that's where our loops are going to go. And then we also know if statements are what help us ask questions, right? So like, is 3 divisible by 2? Is 4 divisible by 2? Those are probably going to be if statements, right? And we can talk in terms of loops, and we can talk in terms of if statements without worrying about the actual syntax of what we're doing. So let's analyze this set of things and just look for what is repeating, right? So I see a repetition that's pretty common here. So anytime you see just the same line over and over again, but one thing changes, that's an ideal place for a loop, right? So we see this repeated, and we also see that if we get all no's, then at the end it's prime. But if we get even one yes, just one yes, means that it is not prime, right? So we know that this is probably part of a loop. But also this major structure is repeated, so we determine whether or not something is or isn't prime. We go on to the next number, then we start asking questions, some number of questions, and then we determine whether or not it's prime again. So I can see, since there's like two major structures, so I can see since there are like two major structures here that are repeating, we have to kind of think, how does it start and how does it end? So since we say one doesn't count, what we do is we check to see, we start checking at 2, right? So, given a number, an input number, right? What we do is, like n is 10, we go up to 10, and we check to see each number whether or not it's prime. So for every number under the input number, check, and then I'll just put an indent just to kind of mentally know, oh, this is inside the loop, right? Check to see if the number is prime. If it is, mark it as prime. If it isn't, mark it as not prime. And then at the end, return the count of the prime numbers. Okay, so that's the broad problem that we're trying to solve. But one thing that we don't have to find out is check to see if the number is prime. So what I'm going to do is I'm going to make another thing down here, and I'm going to give it a label. Is the number, the input number, prime? That's the label of this second problem that I'm trying to solve. Because check to see if the number is prime is not enough, right? There's a bunch of stuff going on in here that helps us to check to see if the number is prime, right? So, given an input number, for every number under the input number except 1, check to see if that number can be, check to see if the input number can be divided evenly by the other number. Okay, if it can't, move to the next number. It can, the number is not prime. So that kind of describes what we're doing here, right? Like we ask to see every number underneath it, underneath 7, and then we determine that 7 is prime, right? So that's one decision that we made about 7. But in order to do that, we had to ask several questions. And so that's why we have this for loop here, right? Now again, this is not code. This is just an outline for the code that we need to write.